Welcome back to Machinist Made. Today we are going to go over how to import a Vise and how to also set a machine up for our full simulation processing. So this importing process is true for anything you're going to do. It doesn't matter if it's a Vise, a fixture, some kind of fixture plate, custom fixturing, doesn't matter. It's all going to be roughly the same. So first thing we need to do is figure out how big our stock actually is. So if you don't know and you're working on somebody else's drawing, you can right click on the setup, go to edit, work your way over to stock, and you see this stock is 3.1 by 3.1 by 1.35. And they have elected to leave 10 thousandths on top of the stock. Now, I know from personal experience, this is not a correct stock size. You're not going to call the material supplier and go, hey, I need to get 3.1 inches stock. They're going to go, we don't have that. A nominal stock size would be 3.25 inches all the way around. And again, 1.35 inches is not a standard stock size. So we're also going to change that as well to 1.25. 10 thousandths face pass is okay, but I'm going to change it to 20. That's what I prefer. And again, this is done by model position Z+. That's going to give us our 20 thousandths. Now I want you to see when I click OK, these check marks are going to turn orange because we have changed the model. Now there's nothing wrong with this. We didn't add enough material to really hurt anything. So we're going to right click and we're going to regenerate. I wish it said regenerate other than generate, but this is Fusion's terminology. So once you click generate, it's going to walk back through all the processes. This process right here, you'll see there's a yellow triangle. It's telling you safe distance is higher than the feed height. That's fine. Then it's going to tell you toolpath safe distance is higher than the feed height. Again, that's fine. It's not going to hurt anything. Next thing that we do is we need to actually model this. Because once you go back into design, your material goes away. The way I like to do this is just create a sketch right on top of the part. This part is pretty simple. It's just a square. So we'll create a square. Right here's our 2-point rectangle, corner to corner. Rotate this around. Click on Finish Sketch. Once we've done that, we can extrude a part. Click on that surface. Make sure you click on both features. See how one selected the face, the other one selects the whole area. Now, keep in mind, we've got 20 thousandths worth of material on top of the part. So we need to extrude two different directions. We need to extrude up 0.02 and we need to extrude down 1.25 minus 0.02. I could have done the math, but honestly and truly, I'm just lazy and I'm going to let this box do the work for me. Anything you type into this box is a fully functioning calculator. Once we've done that, we'll go to our operations. We don't want to cut it because it's going to make our model completely go away. We want to create a new body. This new body represents our stock. So we click on new body. You see the body's there. We can now click OK. And now we know the exact size of our stock that we're dealing with. Except one thing. I made the square to the size of the part, not the size of our stock. I did the correct height size. I did not do the correct width size. This is somewhat intentional to show you how to make this option change. So go back to your sketch down here at the bottom by right clicking, edit sketch. Now we know the material is a 1/4 inch bigger. We can go up here to offset, click on our rectangle, and we can change this to be a 1/4 inch bigger minus 125. Now I'm doing 125 thousandths, and it's negative because it's pushing it to the outside. I'm doing 125 thousandths because that's on all four sides. 125 plus 125 equals the 250 that we added for material. We can now click Finish Sketch and right click on Extrude, edit that feature, and we can just add that feature to it by clicking the empty rectangle. Again, this is what it will come up like. I just have to click the outside rectangle area, and all of a sudden I've got a fixed stock. Now we can click OK. This is our true stock size with our part inside of it. We can now work on importing our vise. Now, when it comes to importing vices and fixtures and fourth axis and all this stuff into your machine, it's relatively easy. Only thing you got to do is get a hold of a manufacturer's STL file or whatever flavor they're using for a file extension for their solid modeling and import it into Fusion. Now today I'm going to be using 5th Axis's V562. This is a very common vise that has been on the market for quite some time, and a lot of companies really love this vise for a lot of different reasons. To use this vise, we left click and hold. You should see a red circle with that slash through it and a picture of the object. Now that red circle with the slash means I can't drop it here. But watch what happens when I slide over. I can drop it into my model. You let go of your left click and it's in there. At this point, we need to position our vise into the correct location. That's what these arrows are for. You can click them and pull them down, or you could actually go over here and type in true position. So let's do -7 inches. That's pretty close. So we want to make some small adjustments from here. 7.1, too much. What about 50 thousandths? It's also too much. 25 thousandths, again, too much. 20, almost there, but I want you to notice this small little gap. That does matter. 15 thousandths puts us pretty much dead on. If you can't see, just zoom in. Simple as that. Make sure your part is in the correct position top to bottom, which basically means put your material on the bottom of the vise jaws. Once you've done that, you can simply click OK. At this point, the only thing we have left is to open these jaws to where it's actually holding the material. If you look where your model actually is at, you down click on the arrow, you down click on joints, and I've used this vise quite a lot, so I know the rear jaw, if I right click and drive joints, will drive both sets of jaws at one time. Now this vise can be operated two ways. You can operate this vise from the internal or external depending on what you're doing. So we're going to get close, and then we're going to start changing our numbers so we can get more exact. In my instance, it came in at 1.525 is how much the jaw needed to move. Now we've got our part with its stock in the vise. We can click OK. Now we are in the actual position we will be machining in. Once you get this done, you can go back to manufacture by clicking on design at the top, and now you can see the stock, the part, and the vise riser. Now we no longer need the actual model of the stock. So beside models, we can click down, then we see tutorial 6, click down on that, and then you see this big tile. Now we obviously don't need all this. So we go to bodies, because remember, when we created that stock, we created a body, not a model. Body 2, body 1 is your actual part, body 2 is the one we created. We can hide that for the machining process. Now once that's done, we can close that arrow, right click on setup, and simulate it again. And it will show us our part being machined all the way through. Again, this is a very simple part, nothing complicated here. And the only thing you're watching is to make sure you've got proper clearance. If you've got this modeled correctly, you've got it modeled in the actual place it's going to be, you can actually see what the part will look like inside the actual vise. Once we verify and validate that this is going to work, we click exit simulation, and then we need to add a machine. Very simple. Right click on setup, edit. So you see this tab under machine, we mash select. We go to the Fusion 360 library. I'm going to use a Haas brand machine, and I am going to use a UMC 750. I'm going to use the legacy design because I actually like the older design of the machine versus the newer design, plus you can see better inside this model. Click on the model, click select. It's going to ask you to download the model. You're going to download it in your folder of choice. You can put this model anywhere you want to. I'm going to put mine under admin projects, same folder that my Vise is in. I'm going to select save. You're going to wait a few seconds because Fusion has to do all the modeling and has to do all the uploading and stuff. Once that's done, it's going to give you another file name. Again, you need to save it as well. That's basically a unique extension to that model for your folder. Would you like to download the machine connector? I don't, so I always click no. It doesn't bother the machine, it doesn't hurt anything. I honestly don't know what it does. I probably should research and find out what it does. So now that we have the machine in here, we can position it. Notice it says Haas UMC 750. Now you'll see the machine comes in a wireframe style design. Now some people complain that it's hard to see, and I kind of agree with them. Same thing as we did in modeling, you grab your arrows and you pull up and down, and it just happened to be that this one is really close already, but I can still see some of the red down inside that gray right there. I don't know if you can see that on your screen, but I can on mine. So we will start changing this by very small measurements. 25 thousandths seem to have done it. And now our model is inside of our machine. We mash OK. The only thing else you would have to check is to make sure the bolt holes would line up with the actual T-slots of the table. But because everything is being made on center here, it all lines up in my case. But if not, you would shift it left and right and back and forth and X and Y to be able to line it up exactly where you want to. Now that we've got this done, we can go back to a normal view. You'll also see down here under your setup, you have a Haas UMC 750. You can right click on setup and now simulate with machine. This is going to actually simulate the part being run with the spindle of the machine. Again, Fusion does not do crash detection. It's going to tell you that over here. Machine simulations does not currently check for machine collisions. It won't. This is up to you as an operator. If you want to buy software that does machine collisions, you're more than welcome to, but it's not going to be at the same price that Fusion 360 is at. So now that we have verified everything looks great. Congratulations. If you were following along, you have now completed this project. I hope to see you back here. Don't forget, like always, to like and subscribe for more content. I'm going to try to post more Fusion videos in the upcoming weeks. So make sure you like and subscribe, and I hope to see you back. Have a good one.